All right, all right, all right. So it says the area of a rectangle is 2x squared plus 17x plus 21, and the length of the rectangle is x plus 7. What is the width of the rectangle? So what operation am I using here?
Division.
Yes, division. So I'm going to be dividing 2x squared plus 17x plus 21 divided by x plus 7. We probably have. What, babe? I don't know. Well, I must have. I probably did not. Okay, thank you. Okay. So to do this, I know that I'm kind of writing black on black here, so sorry about that. X times what will give me 2x squared?
2x.
2x, uh-huh. Okay, yeah, you definitely cannot see that. Let me just do that here. So 2x. So rude. All right, so 2x. So then up here on the side, I'm going to go multiply 2x times x plus 7. 2x times x will give me 2x squared. 2x times 7 will give me 14x. So I'm going to write that underneath this and subtract. 2x squared minus 2x squared. 17x minus 14x. So that gives me 3x. Bring down the plus 21. And so I'm starting that process over again. X times what will give me 3x? 3. And this is the answer to x plus 3, but I could go out and do the 3 times the x plus 7 over here. That would give me 3x plus 21, and I would put that underneath here, and that would all just cancel out. So the answer would be 2x plus 3.
Is that typically how like a normal problem would go? Like we're able to have an equation and it doesn't get like more complicated than that?
Yes, for algebra 1, yes.
Okay.
When you get...
You mean for algebra 2 we have the harder ones?
So for, oh my goodness gracious, I'm literally trying to write 2x. That's not even the right answer. Oh my gosh. For algebra 2, you're gonna have it where you're gonna have a remainder. So like, for instance, this 3x plus 21, it wouldn't cancel out with this, and you would have to figure out the remainder and yada yada yada. Okay, whatever. My pen's just not working. Okay. All right, let's review from last class. Not last class, but last class. With with exponent laws. I am awake today. I'm awake.
Are you sure?
I am. Okay. So, anyone have an idea what you would do first? Oh, yes, the exponent, the power rule. So everything in here is being raised to the power 2. So 8 is being raised to the power 2, x to the power 2 is being raised to the power 2, y to the power 3 is being raised to the power 2. So what's the rule when I raise it to a power? What do I do with the exponent?
You multiply.
I multiply. So I'm going to write it down here. So that would give me 64 because 8 squared is 64. X to the power 4 because 2 times 2 is 4. And y to the power 6 because 3 times 2 is 6. And multiply that with x, z, 3 all over. And I'm going to do the same thing. This down here is being raised to the power 3. So I'm going to go ahead and do that rule as well. So 2 to the power 3 is 8. Yes, 2 times 2 times 2, yes, 8.
Yeah.
X to the power 3 will be x to the power 3. And y to the power 2 to the power 3?
Y6.
Y6. And then all multiply to z. Huh?
Miss Patterson,
Yes, Jaden?
could you go back to the other one?
Like the first slide?
Yeah, unless like your work was erased.
No, my work is just not, it just was not writing very well. I'll go back to it in a minute, okay?
Okay.
All right, from here, am I simplified all the way?
No.
No. So what would I do next?
Can we cancel out the y?
You could, but before we do that, how about like what I like to do?
Oh, 64 and
divide.
8. Yeah. Let's do
Divide
that
the
first.
64.
Oh, okay.
Oh, yeah.
Yes, you can. But what I like to do
Oh,
first,
yeah.
what I like to do first is if on the numerator, if there's stuff I can still combine together, I do that first, and then I'll start with then I'll do my division.
Yeah, add the x to the x4.
Yeah. So the x's, there's two x's on top, so I'm gonna go ahead and multiply these. And when I multiply, what do I do with their exponent? Add them. So this is x1. So this would give me 64, x5, y6, z3, all over 8x3, y6, and z. Now
Wow.
we can divide.
Okay.
And when we divide, what do we do with the exponents?
we
Subtract them. Oh my goodness, this is like music to my ears. Good job, guys.
I'm so proud.
So 64 divided by 8,
8.
8. X to the power of 5 over x to the power of 3.
X to the power of 2.
Yep, that's 5 minus 3 is 2. So x to the power of 2. Y to the power of 6 over y to the power of 6.
Cancels out.
Yeah, it cancels out because it's y to the power of 0, and that equals anything to the power of 0 equals 1. Oh my gosh, yes. Okay, so y's just cancel out. Z to the power of 3 over z to the power of 1.
Z to the power of 2.
Yep, and there's my answer. I'm very impressed right now.
I'm gonna take a picture with this because I'm not gonna remember.
Like, I'm so impressed. I am happy. Like, oh my goodness. Oh my goodness. All right. So I think today's lesson is fairly simple. And I think we should have time at the end of class where everyone finishes everything. Then I'm going to go check Canvas and make sure everyone has turned in stuff. If not, that's what you're working on at the end of class, okay? All right. Jaden, remind me at the end of class to go back to the warm-up, okay, babe?
Okay.
All right. So you can title your notes today, Factoring, 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 Factoring. Oh, no. So today we are factoring.
Calm down. I'm trying to break my algebra and it's like a factoring.
Factoring trinomials. You want another pen? Okay. All right. Yeah, sorry. I think my brain and my ears is just not registering today. Huh? Green. Oh my gosh, Twizzies.
Great minds. Oh my god.
All right, so factoring trinomials. So go ahead and write this down. Ax squared plus bx plus c. Ax squared plus bx plus c. What we're starting to transition into is into quadratics. So we've done linear for the first 9 weeks. This 9 weeks, we're doing quadratics. So we're starting to go into what quadratics are. But before we're doing that, we're starting off with factoring. Can anyone guess why this is called a trinomial? Oh my goodness. So there's 3 terms. Oh, beautiful. So that's why this is called a trinomial. A and B would be, you don't have to write this part down, but A and B, hopefully we understand that these are called coefficients because it's the number multiplied to the variable. And C is called your constant term. Okay, you don't need to write that information down, but we do need to write this down. This right here is called the standard form of a quadratic equation. And we're going to be using it for this week when we're factoring trinomials. So let me go to, so you know how last week maybe it was, or the week before that, we multiplied two binomials. So for instance, x plus 3 times x plus 2. Remember this box method? X squared, 3x, 2x, and 6. And that gave us x squared plus 5x plus 6. Okay, and so we multiplied two binomials and it gave us a trinomial. Now what we're doing is we're going backwards. You're going to be given a trinomial and you want to figure out, well, what two things multiplied to get me that trinomial? Okay, so let me say that again. Last week or whatever, we multiplied two binomials and it gave us this trinomial. This week, what we're doing is, here's this, go find what these two things are. So you're trying to figure out what two things, which are called factors, what two things would have multiplied to get me this without this information right here, okay? So I'm going to show a video on YouTube, which I think I showed every year. And to me, he explains it absolutely well. And it's like a 2-minute video. I probably should have had it pulled out beforehand, but whatever. Yeah, this dude.
Grammarly
Yes, he
does
was.
more than catch errors. With Grammarly, you can find really good.
Thanks, Grammarly.
All
right, so try to follow along with what he's saying. Okay.
They called me the F.
All right, there we go.
That's right, you guessed it. I played football, and you know what they called me out on the field? They called me the X Factor. You know why? Because I was the most important player on the field.
Oh.
Whenever they needed help or whenever they needed to score a touchdown to change the momentum of the game, they called up for the X Factor. And I would get the ball and score a touchdown. So now I'm going to show you what we can use using the X to help us when we're factoring in math. It's a little technique, but go ahead and pay attention to this. It's really cool. So if they ask you to go ahead and factor the trinomial and you have something like this, the first thing you want to notice is that there is no coefficient. So there can't be a coefficient in front of this x squared, but it could be x squared, it could be a squared, it could be any variable squared. There can't be a number in front of it. So now once we see that, we call upon the x. So the x will be our momentum changer for this. So I want you to go ahead and draw a big X right here. And what you do.
Okay, so I would try, maybe I would try to follow along with him real quick, okay? And see, really pay attention to what he's saying and what he's doing with this X, because that's what we're going to do all day long today, okay?
Now is you drop down this number. So you drop down the 13 and we put it right here. And then you take this 42 and you put it right here.
Okay, so I'm going to pause. Got to see some people are trying to write it down. You think you know the answer?
Yeah, so what's the name?
Good job. Robert's like,
Now, you want to pay attention to the signs as well. This is a positive 13, so let's make sure we put that there. And this is a positive 42, so we want to put that there as well. Okay, now that we did that, we realized because since there's no coefficient in front of this variable square, we call on for the x, and that's the most important thing to do. Now we have to ask ourselves, what two numbers add? So they have to add to positive 13 and multiply to a positive 42. This is the toughest part, but trust me, it beats guess and check. So now, if we know our multiplication facts, we would know that 6 times 7 is 42, and it has to be a positive 42. So it would be a positive 6 and a positive 7. Why are they both positives? Well, because it also has to add to a positive 13, right? So now we know that positive 6 plus positive 7 adds to 13.
What?
And positive 6 times positive 7 adds to 42. So now we're ready for our answer. So what's our answer going to be? Let me show you. You take whatever this variable squared is right here, and you go ahead and take the square. So x squared would be just x.
He
And
says
now
the square
you
root.
go ahead and put x plus 6. And then you put another x in the other binomial. X plus 7. Where did these numbers come from? Well, I just took plus 6 and I put it there. And I took the plus 7 and I put it there. Or the positive 6 here and the positive 7 there. Now, a lot of questions I get asked are, what happens to this x right here? You don't have to worry about that because we're factoring. When you FOIL everything out here, you'll notice that once you combine like terms, you'll get that as your answer. So when you do this, you just take the square root, put 1 here, put 1 there, and then the numbers go here, and now you got the answer. So now I'm getting a little excited. We're getting
All right, cool. Okay, so that was like an introduction to what we're doing. And that's literally all today.
It's his parentheses.
Why? No, they're so good. Okay, and so that's literally all we're doing today is using that X method, okay, to find our factors. Okay, so this is basically how we set this up. We call it the X method or the diamond method, okay? So every trinomial is set up as ax squared plus bx plus c. Today, we're only doing it where our a is equal to 1. Okay, we're not going to get more complicated today. Only a is going to be equal to 1, so that a will not be there today. You're only going to be using the b, which is the coefficient of x, and the c, which is the constant. So your b is always going to go on top of your x, and you're trying to figure out what adds to get you that b value. Your c is going to go on the bottom of that x, and you're looking to see what multiplies to get you the c value. Once you find those two numbers, bam, there are your factors. So what I would do is have this little diagram up so you can like refer back to it quickly when we're doing our problems today. All right, you ready for your first example? All right, let's do this.
No.
Oh, okay. He kind of pumped me up, like I'm like feel like tackling this lesson today. Yeah.
Yeah, Robert.
Yes.
We didn't do good things.
I'm so sorry. I am so sorry. All right, lovies. All right, so let's do our first example. X squared plus 7x plus 12.
So miss, those two numbers have to multiply to equal 12 and add to 7?
Yes. Okay, so please, if you know it, don't say it out loud. I want to make sure I go slow enough and explain it slow enough for everyone to get it.
Oh, you're calling me out.
No, I'm just saying in general.
Yeah, like so.
So we're trying to factor x squared plus 7x plus 12.
I finished that.
So we put our b value on the top of our x, and we're trying to figure out what adds to get 7. And we put our c value on the bottom of the x, and what multiplies to give us positive 12. Now, some of you are probably already thinking of two numbers that add to get you 7 and multiply to get you 12, but don't say them out loud. Now these numbers are simple, but when the numbers get higher and harder, this is something you could do. you can take your 12 and list out the factors of 12. So what are some things that multiply to give us 12?
12 times 1.
12 times 1.
4 and 3. Wait. Yeah.
Yeah, so 2 and 6, 3 and 4. Anything else?
Nope.
No. So then when you list out the factors, 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. When you list out the factors of 12, you can figure out, well, which pairs would add to get me 7 as well.
3 and 4.
3 and 4. So these are my two factors, the positive 3 and the positive 4. I know. So this is how I write out my factors. It would be x plus 3 times x plus 4. So we're just taking what our two numbers are with the and putting it with the variable. X plus 3 times x plus 4. And this is because if I actually multiplied x plus 3 times x plus 4, it would give me x squared plus 7x plus 12. It should multiply together to get you what your original trinomial was.
So is that how you check your work?
Yeah, so if y'all ever see me, like whenever before, I don't know if y'all ever saw me when we were doing this, I would do this really quickly to try to figure out the answer and then give y'all the question. So yes, this is a way to check yourself. Multiply it back out, see if it gives you your original trinomial. But this is your final answer. This is your final answer, not this. This is your final answer.
Negatives, yeah.
Yes, yes, we're gonna get into negative. Okay, do I have any questions? This is the easiest it will be. It's not gonna get too much spicier, but this is it.
The next
That's
one's
nice.
spicy though.
Okay, let's look at the next one.
I had no idea.
So here, remember, if there's not a number in front of the x, that means the coefficient is 1. So draw out your x and put the b on the top. So my coefficient of x is 1, positive 1. And put the c on bottom, which is negative 42. So you have to pay attention to the sign that's in front of there. So you're trying to figure out here what adds to get you positive 1, but multiplies to get you negative 42. Do not say it out loud, please. So I want everyone thinking. I have a negative here. So are my two numbers going to be positives? No. Because if I have a negative, I know one of my numbers have to be a negative. So start thinking, start thinking. Do not wait on me. Literally, you are not learning if you're just waiting on me to give you the answer. Start thinking. So let's write out the factors of 42. 1 and 42. Give me another one.
2 and 24.
2 and 21, yeah.
Oh, yeah.
Okay, give me another factor.
21.
3 and 14.
4 and 7. No, 6 and 7.
6 and 7. Okay, I'm just gonna write all these out. So here's my question. Okay, this is where 6th grade math comes back into play. If you're looking for a number that multiplies to get you negative 42, but adds to get you positive 1, you know, one of the numbers has to be negative and the other number has to be positive. But if it's adding to get you a positive, the bigger number has to be the positive one. Okay? If I'm adding two things together and one is negative, one's positive, if the bigger number is positive, my answer is positive. If the bigger number was negative, the answer would be negative. So what I'm going to do is I know my bigger number has to be positive. So the smaller numbers, I'm just going to put negatives on them. Which two would add to get me positive 1, but multiply to get me negative 42? Perfect. Negative 6 and positive 7. Negative 6 and positive 7. So -6 and +7. -6 plus 7 is +1. -6 times +7 is -42. If there's confusion, I need to know. Okay, so my answer is x minus 6, x plus 7. X minus 6, x plus 7. There's no questions at all? Okay.
I mean, what you trying to say, Miss Patterson?
No. I ain't trying to say anything. I'm just saying. Usually I got a question though by now.
No, I'm good.
No, I don't want you
She's
to.
already ahead of us. She's like done with everything.
You're already doing the assignment?
No, I'm working on the okay. PowerPoint. I'm just on the second to last one.
All right, so let's look at this one. Everyone, try to figure out the answer. I'm gonna give you 1 minute to try to figure out what two numbers add to get us -6, but multiply to give us +7
+7.
and +8. What is wrong with me? Really quick though, my question is, if it adds to get me -6, but multiplies to give me +8, your two numbers have to be what? Negatives. Okay, good. Awesome.
These are actually kind of easy when you
Cool. All right, someone other than Noah and Alexa, can someone tell me what the two numbers will be, Sophia?
-2 and
Beautiful. -2 and -4. Because -2 plus -4 is -6. -2 times -4 is +8. So it'd be x minus 2, x minus 4. Okay? Okay. Mm-hmm. Okay. All right. We're gonna.
Are we gonna do the difference?
Yeah. So that's why I'm skipping some. Let's do this last one. Everyone do it. I'll call on someone random. So here I didn't put the numbers in for you, okay? Because some people lean on me way too much. So what am I gonna put at the top of my x? -1. And what am I putting at the bottom? Beautiful. Beautiful. Patterson. Yes, this is yes. Yes. Hmm. No, because they have to multiply to give you a negative. So one's gonna be positive and one's gonna be negative.
How long?
Oh, okay.
Usually 20 to 30 minutes. So like, I don't know who it was on the phone, but okay, so
I go way too much. No, like seriously, I've had way too many morning problems.
it's okay.
We didn't know that, so.
All right, so you're trying to figure out what numbers add to get you -1, but multiply to get you -12. Well, if you know it's multiply to get you -12, one of the numbers has to be negative, the other has to be positive. Because they're adding to get you a -1 or negative, that means the bigger number has to be negative. So I always just list out my factors. I know the bigger number has to be the negative one because they're adding to get me -1. Robert, you got it? Oh, okay. Who said that? Jaden, go ahead then.
Is it -4 and 3?
Perfect. +3 and -4. Because +3 plus -4 is -1, and +3 times -4 is -12. So my two factors would be x plus 3, x minus 4. Okay, I'm literally done with the x method right now. I need to know if there's questions. I'm skipping because for some reason it feels like this is taking longer than normal. Or maybe we just started late. I don't know.
I think it was because we started.
I think it's because we started late. Okay, so I'm trying to be finished in the next like 10 minutes. Okay. The last thing we're going to learn is the difference of squares. Okay. Back in 8th grade, and I know I skimmed over it very slightly. Okay. We did stuff with squares. Do y'all remember the word perfect square at all?
I feel like
All right, I'm gonna list them out, and you don't need to write all this down. I'm gonna list them out. Tell me if you notice a pattern. Oops. All right, I'm gonna list them out. That's 16.
Is it? Oh, no. Like when you're like.
Oh yes, yes. Oh.
And
okay. Yeah, I know what you're. Okay.
I know what it's supposed to be. I don't know how to describe.
Y'all say
I know.
It's like that little equation.
No. Okay. So one squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, all the way down to
Yes.
10.
So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9.
Yes.
10 times 10.
squared is
So
100.
the square root of these numbers is a perfect whole number. So the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. So forth and so on.
Are we ready?
No, you don't have to write this down. Okay. You can to help you with this, but you don't have to write this down. Okay. So the perfect squares are numbers that if you square root them, it would give you a whole number. Okay. So, and the square root is just what number times itself equals that number. So when we're working on the difference of squares, you need to know your perfect squares, okay? You need to know that the square root of 100 is 10. The square root of 121 is 11. The square root of 144 is 12, okay? So these are things you need to know off the top of your head, okay? Now, should say difference, not different. These are a little bit more difficult than what we just did. So I need you to really kind of hone in. I know that I've been talking for too long. Okay. The difference of squares. This rule only works for binomials. Why am I saying binomials? There's two terms. And they have to have difference. What's difference mean? Difference.
Yeah,
Whenever I'm saying what's the difference of this? Subtraction. Okay. So they have to have a subtraction sign. So these are the things. It has to be a binomial, and I would write this down. Has to be a binomial. Has to have a subtraction symbol between the two terms. My pen is just obviously not working today, so forgive me. And they have to be perfect squares. You cannot even read that. I am so sorry.
Totally fine.
Okay, so it says binomial. They have to be a binomial. There has to be a subtraction symbol in between the two. And they have to be perfect squares. They have to be perfect squares. Meaning, if I took the square root of them, it would give me a whole number. I can't hear you. Killed her fish?
Can write better than
Oh my Thanks. No, it's not me in my writing. It's the pen.
Yeah.
Whatever. Whatever. Yes, I do have good handwriting. Okay, everyone write this down. X squared minus 9. X squared minus 9. Okay. When I start saying it, you're gonna get the hang of it. X squared minus 9. X squared minus 9. Write it down, please. Okay, you want to find, we're trying to find what the factors of x squared minus 9 is. We could use the x method here. We could. All right, we could. So I'm just going to write this down real quick. But what's the b term?
There is none.
There is none. No, it's not 1 because you would see a 1x. You would see an x there.
Yeah, Robert.
So there's nothing, right? 0. What's the c term?
Negative 9.
-9. So you could do this. What adds to give you 0 and what multiplies to get you -9? No. Has to add to get me 0. Let me write out the factors of 9. 1 and 9, 3 and 3.
Oh, -3 and negative, or positive.
-3 and +3, right? So my factors would be x minus 3, x plus 3. But we can go ahead with difference of squares. We don't even have to do all this. What you're going to end up being able to do is, oh, this is a binomial. There's a subtraction sign between them. And they're perfect squares. What is the square root of 9?
3.
3. Because it is, I know that both of my numbers were going to be 3. One's going to be minus and one's going to be plus. And that's all. So I'm going to do another example. I'm going to show you what I said again. Here, it's a binomial. Okay, I need like 5 more minutes. It's a binomial. There's a subtraction sign in between the two. 100 is a perfect square and 4 is a perfect square. What is the square root of 100? 10. What's the square root of 4?
2.
So my answer is 10x plus 2, 10x minus 2. Those are my two factors.
Oh.
Okay? So the difference of squares says, take the square root of both your terms, and one's going to be addition, one's going to be subtraction, and there's your factors. So the difference of squares says, take the square root of both your numbers, and then one's going to be addition, one's going to be subtraction. Okay, let's try one. Let's try another one. All right, let me just write it down. Okay. Oops. What if I had 25x squared minus 121? Mm-hmm. Perfect. Perfect. So I take the square root of both numbers and put a plus and minus sign in between. Let's try another one. This time, Noah can't answer.
7 plus 10.
Mm-hmm.
And then 7.
Perfect. Beautiful. Wonderful. Amazing. One more, and I'm done.
Plus 30.
6x plus 3, 6x minus.
Perfect. Okay, and that's it.
Yay.
Oh, this only works if there are two perfect squares, a subtraction sign in between, and there's a binomial. That's the only way it works. Okay, how do we feel? Can I get a thumbs up, thumbs down, thumbs sideways? How we good? Good, good, good. Awesome.